Hello, in this video, we're going to be going over the first part of lesson 3.3 on proving lines are parallel. In the previous lesson, 3.2, we learned that if we know two lines are parallel and they're cut by a transversal, that we have all of these different relationships with our angle pairs. Like corresponding angles are congruent, same side interior angles are supplementary. Well, this lesson is going to be using those theorems in reverse. So we're going to try to see what angle relationships can be used to prove that two lines are parallel. The first way that we can prove that two lines are parallel is if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. This is just the converse of the corresponding angles postulate, because the corresponding angles postulate states that if two parallel lines are cut by a transversal, then corresponding angles are congruent. Here, we're going in the reverse direction and saying if two lines and a transversal form corresponding angles that are congruent, then the two lines must be parallel. So in our picture right here, if we were given that angle 1 was congruent to angle 2, and you can see they're marked in the diagram. So given angle 1 is congruent to angle 2, that would be enough information to prove that line L is parallel to line M by the converse of the corresponding angles postulate. There's also a converse for alternate interior angles. And this states that if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. For a diagram here, we're given that angle 1 is congruent to angle 2. Notice that angle 1 and angle 2 are alternate interior angles. Well, the converse of the alternate interior angles theorem states that if two lines and a transversal form a pair of alternate interior angles that are congruent, then the lines must be parallel. So here, once again, with that relationship, line L must be parallel to line M. Next, we have the converse of the alternate exterior angles theorem, and this states that if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. Here in our diagram, angle 3 and angle 5 are a pair of alternate exterior angles. So if I know that angle 3 is congruent to angle 5, we can use that to prove that line L is parallel to line M by the converse of the alternate exterior angles theorem. All right, the final converse theorem is the converse of same side interiors. Now, if you remember back from lesson 3.2, same side interior angles are not congruent, they're supplementary. So for our converse here, it states that if two lines and a transversal form same side interior angles that are supplementary, meaning they add to 180, then the two lines are parallel. So in our picture here, if we knew that angle 2 and angle 4 are supplementary, we would be able to prove by the converse of the same side interior angles theorem that line L must be parallel to line M. It's important to note, though, that some angle relationships do not work to prove that lines are parallel. And one of those is the vertical angles and linear pairs cannot be used to prove two lines are parallel. Because no matter what, vertical angles are always congruent, whether the two lines are parallel or not. Similarly, linear pairs are always supplementary. So that's not enough information to prove that two lines are parallel. The only way we can prove two lines are parallel is to use one of these four converse theorems. For our first example here, we're going to practice using the converse of the corresponding angles postulate. and the given information to show that line L is parallel to line M. Notice in our picture, we have 8 angles, and we're given here for this first one that angle 4 is congruent to angle 8. Notice that angle 4 and angle 8 are corresponding angles. So I'm going to observe first, it's given that angle 4 is congruent to angle 8, and then we're noting that angle 4 and angle 8 are corresponding angles. Okay, well, since we have a pair of corresponding angles that are congruent, we would be able to conclude that L is parallel to M by the converse of the corresponding angles postulate. For letter B, we are given that the measure of angle 3 is 4x minus 80 degrees, and the measure of angle 7 is 3x minus 50 degrees. First, let's find those in our picture. Here's angle 3 and angle 7. And we're given, so for angle 3, we have this expression, and we are given that x is 30. So what I'm going to do is I'm going to substitute in the 30. So 4 times 30 minus 80. And if you plug that in there, 4 times 30 is 120, and 120 minus 80 is 40. So here I just use substitution, and I substituted the x value of 30 into this expression for angle 3. Let's do the same for angle 7. The measure of angle 7 is 3x minus 50, so that's 3 times 30. Minus 50, and if you simplify that all out, you also end up with 40. Again, I used substitution. Well, now notice that both of these match up. You can see right here that we have angle 3 equals 40 degrees and angle 7 equals 40 degrees. So we would be able to say that since two things are equal to 40, they have to be equal to each other. On my next line then, I'm going to state measure of angle 3 equals the measure of angle 7. And for that, we could use the transitive property. Of equality. Well, if the measures of angle 3 and the measure of angle 7 are congruent, then angle 3 must be congruent to angle 7 by definition of congruent angles. And now, since we have a pair of congruent corresponding angles, we would be able to say line L must be parallel to line M by the converse of the corresponding angles postulate. For this next example, we're going to determine whether the information given is enough information to prove that two lines are parallel. So in this case, we're going to see, do we have enough information to prove that M is parallel to N? If we can prove that the lines are parallel, we'll justify it with one of our converse theorems or postulates. And if we can't prove that they're parallel, then we'll explain why. So the first one here says angle 3 and angle 4 are supplementary. Let's notice that angle 3 and angle 4 are a linear pair. And linear pairs do not prove that two lines are parallel. So we're not able to prove that M is parallel to N because 3 and 4 are a linear pair, and linear pairs are always supplementary. In fact, we would not even need this part of the picture in order to know that angle 3 and angle 4 are supplementary. A linear pair does not require lines to be parallel. All right, let's check out angle 1 and angle 5. Here's angle 1 and angle 5. They are congruent. Notice that angle 1 and angle 5 are a pair of alternate exterior angles. And we know by the converse of the alternate exterior angles theorem that M is parallel to N. And I'm using the converse of alternate exterior angles theorem. How about angle 2 congruent to angle 6? Let's find those. Well, angle 2 right here and angle 6 right there are a pair of alternate interior angles. And the converse of the alternate interior angles theorem states that if two lines and a transversal create a pair of alternate interior angles that are congruent, then the lines must be parallel. So M is parallel to N by the converse of the alternate interior angles theorem. All right, now let's look at angle 3 congruent to angle 5. Here's angle 3, here's angle 5. Notice that 3 and 5 are vertical angles. And vertical angles are not one of the ways that we can prove lines are parallel, because vertical angles are always congruent. So the two things that are not able to prove lines are parallel are linear pairs and vertical angles. That's going to be important to note. Linear pairs can't prove lines are parallel because no matter what, linear pairs are always supplementary. Same thing for vertical angles. Vertical angles don't prove that lines are parallel because vertical angles are always congruent whether they're parallel or not. The four ways that we can prove that lines are parallel are corresponding, alternate interior, alternate exterior, and same side interior. Here's a try now for you to try on your own. We'll determine whether the following information can be used to prove that segment AB is parallel to segment CD, and if you can prove that the lines are parallel, justify with a theorem or postulate. If you cannot prove they're parallel, explain why. Please try this on your own. I'd like you to pause your video now, and then when you hit play, I will have the solutions posted and we'll discuss them. Please pause. Here are your solutions to the try now. For A, we have angle 4 congruent to angle 8. Notice that 4 and 8 are a pair of congruent corresponding angles, so the lines are parallel by the converse of corresponding angles postulate. For letter B, we have angle 4 and angle 6 are supplementary. Notice that 4 and 6 are a pair of same side interior angles, and if same side interior angles are supplementary, the lines are parallel by the converse of the same side interior angles theorem. For letter C, we have angle 2 is congruent to angle 7. And notice that angle 2 and angle 7 are a pair of congruent alternate exterior angles. So the lines must be parallel by the converse of the alternate exterior angles theorem. For letter D, we cannot prove that the lines are parallel. So angle 1 and angle 7 are not one of the angle pairs that can be used to prove lines are parallel. And angle 2 and angle 3 also does not work because 2 and 3 are vertical angles, and vertical angles do not prove that lines are parallel. Vertical angles are congruent no matter what, whether the lines are parallel or not. This concludes the day 1 portion of the video. We'll go over the rest of the lesson, the last 2 examples in 3.3 day 2. Thanks for watching. Bye.